When you ask people what edge compute is, you get a range of answers. Cloud compute and DevOps with devices and sensors, with semiconductors outside the data center, including connectivity, AI, and a security strategy. It's a stew of technologies that's powering our vehicles, our buildings, our factories, and more. It's also filled with fascinating people that are passionate about their tech, their story, and their world. I'm your host, Pete Bernard, and the Edgecelsior Show makes sense of what edge compute is, who's doing it, and how it can transform your business and you. So let's get started. Cool. Well, Bob, thanks for taking the time.
Yeah.
Really appreciate it. And, we met at Mobile World Congress, and that kind of weird Italian restaurant. What was that? I don't even know the name of the place.
Pietros.
It had those monkey paintings on the wall.
Yeah. That thing has been used by people for CES and other Vegas convention meetings for literally decades, not just years.
Oh, I was going to say
decades.
Generations.
Yeah, well, that's probably true.
It seemed like it was a little time capsule in there. But anyway, no, it was great to meet you there. And, that was actually my first show as kind of an Edgecelsior person. And so I'm sort of, wading into a lot of this analyst and consultancy business. But I know you've been doing it for a long time. I was reading up on your bio. In terms of the time you spent at IDC, like 14 years there, you spent 10 years with your own firm.
Yep.
Media influencer for virtual reality and AI and all these things. So it's kind of goes without saying you've been on the cutting edge of a lot of this work for a long time. So
yes. Maybe
you can give me your version of the intro, since I'm kind of just regurgitating your website.
Yeah, no, I mean, I have been I started out in tech related press. I originally started doing music technology stuff. I am a musician, and that's still my passionate hobby. I have a band, and I play guitar, I play trombone, I got keyboards all around me. And then I got from that into computer publications, and from computer pubs, I got into being an analyst. And I started at IDC a long time ago, and then was there for 14 and a half years, and then decided to do my own thing. And it has 1 month from now, it'll be 10 years at Technalysis Research. Right. And then along the way, I did my own call-in radio talk show on an ABC affiliate here in the San Francisco Bay Area. And I've done, I write for USA Today and Forbes and a whole bunch of other places. I've done a bunch of TV for all the big networks, Bloomberg, Yahoo Finance, CNBC, et cetera, et cetera. Yeah. So
awesome. So we're only recording audio here, but if you saw Bob, you might recognize him from one of those talking heads things. But and you mentioned also, so I play guitar. Nice. That was one of the things I had been talking to Leonard about, was her kind of. I don't know if that's a thing, like people that are into tech are playing music too.
There's a lot of people in tech who are also musicians. Absolutely the case.
Yeah. I saw your website for the headliners.
Yes.
The horn band.
Yep.
That looked really awesome.
Yes. Thank you.
Impressive. So it sounds like you guys have some pretty regular gigs too.
No, we're doing all right. There's a gig actually coming up in a couple of weeks. Unfortunately, I will be out of town, so we had to get a fill in for me, I see. But it's, I started the band over 20 years ago, specifically to be a Chicago cover band, because I grew up in Chicago, so I was a huge Chicago fan. And then Blues Brothers, and then we branched off into all kinds of stuff. But it's all horn band based stuff. I've written original tunes for us as well, and so we have a lot of fun. It's a great time.
Cool. Yeah, I've been playing up here with some guys for about 7 or 8 years. I've been playing in bands since, I went to school in Boston in the 80s, 90s. Yeah. So, but these guys have been playing with for a while. It's been a lot of fun. It's a great exercise for a different part of my brain. And it's creative, and I don't know, it's some kind of good visceral thing, when you get into it.
Absolutely.
So it's get out from behind the keyboard every so often. That's cool. Hey, so I saw that you published a document recently, a paper around RAN. And,
yes.
not to get too much in the weeds here, but it was interesting because you were talking about, and I did a little TikTok recently on sort of DRAN, CRAN, VRAN, ORAN, right, the whole evolution. And it's kind of like we're on this track or train of the virtualization of everything.
Yes.
And maybe because as semiconductors are getting faster and networks are getting faster, in general, people are able to now do things in software and in different sort of layers of the cake.
Right.
Then back in the old days, you pretty much had to hard code everything to a custom piece of breadboard, that you put together. And now it's all becoming virtualized. I mean, do you see that as a meta trend that's happening not only in telco but in other places?
Well, yeah. I mean, it started in the computing world, right? I mean, if you think about it, we went to, even mainframes and terminals, for gosh sakes, is a sort of a form of virtualization. You're virtualizing the computing resources of that mainframe. You didn't really virtualize it back then. You actually physically shared it. It was not virtualized, to be fair.
Right.
But quickly it was realized that, hey, there is all these computing resources. How can we use them more efficiently? Like nothing worse than having all these compute resources and then finding that it's only being used 20% of the time, right? So how do we improve that? And so virtualization became a thing to leverage that, and virtualization has, become the thing. And that's how almost everything is done in the computing world. And frankly, the telco industry is about 10 years behind on figuring out this idea of virtualization, because there's a couple things that are different. And that's why part of the reason why telco has moved at the pace that it has. Number one, first of all, telcos are utilities. They're not really tech companies. A lot of people tend to think they're tech companies, and they certainly have tech aspects, but they're a utility. And I mean that in the sense of they need to be there and be reliable like a utility. You need to have that service all the time. Computing has gotten significantly more reliable than it used to be, but if somebody's server goes down, you're going to live, right? You'll come back. When telco networks go down, literally people's lives are at stake. So it's just been a much slower moving process because of that. And the truth is there were a number of companies had dedicated hardware, the Ericssons and Nokias and Samsung Networks and Huawei's of the world, that did a good job of doing what they were doing. But there was this recognition that, hey, we can move this stuff into software, as you mentioned, Pete, and then really get into leveraging, what they call COTS hardware, commercial off-the-shelf hardware, meaning you could buy a standard server from a Dell, an HPE, a Lenovo, and then run this software and then achieve the same things. And then, oh, by the way, not only does it duplicate the functionality, you can do it a little bit more efficiently from a power and cost perspective. And most importantly, you can automate it. And you can automate certain processes and what have you. And you could leverage software written, for one place in other places. So there were a lot of reasons why it makes sense to do it.
Yeah.
It's just taken a long time.
Yeah. And I think, telco, like you said, is tends to be kind of a risk averse business.
Yes.
They had an existing system in place for a long time that worked 24/7.
Yep.
365.
That's exactly what they need.
Getting in there and kind of blowing it up and starting over again was probably not something anyone was really looking forward to doing.
Yeah.
And that's why probably it's taken a while. But like you said, it's when you get into software and virtualization, you get into a lot of risk mitigation. You get into a lot of vendor choice and flexibility.
Yes.
And you get into a lot of theoretically agility in terms of adapting new services and new capabilities on the fly without reinventing the hardware. So it's got a lot of upside, but it's probably a lot easier to do it when you're just getting started as opposed to you've been running a network for 50 years.
Well, and that's, and exactly to your point. That's what we've seen people do. The most rapid adoption has been in these what are called greenfield networks. You look at Dish here in the U.S., you look at what Rakuten did in Japan, and some other places where they didn't have this huge existing infrastructure that they had to work with and modernize. And, in the US and other parts of the world, you've got telcos that have been there for decades. And modernizing that is a lot harder than building from scratch. And so you do it piece by piece, bit by bit. And that's what we're seeing happening. It's taking a while, but it is indeed getting there. And it's opening up new possibilities. And some of the advanced capabilities for 5G, for example, are going to be easier to deploy when everything is software defined.
Sure.
And then eventually, as you said, you talked about the various RAN prefixes. O-RAN is the other big one, Open RAN versus virtual RAN. And Open RAN takes virtual RAN even a step further by saying, hey, we can interconnect.
Mix and match.
Yeah, we can mix and match. Mind you, I think what a lot of people are finding is it's one of those things that sounds great in theory and not necessarily as good in practice. Because of the reliability and what have you, there's this sense of, hey, I need one throat to choke if something happens and goes down. And if I'm intermingling too many different vendors and too many different parts, everybody's going to point fingers at each other and be like,
sure, you're not quite sure what's going wrong there. Yeah. No, I agree. It's it looks good on PowerPoint. I mean, and you're seeing some of the telcos, the challenger telcos like Dish and other folks embrace it. I wouldn't say because they have nothing to lose. They have a lot to lose, but it's at least they maybe are more willing to take chances and try to get the competitive advantage than maybe the geo leader in the telco space, whether it's a Vodafone or whoever that's maybe, probably a little more cautious on their solution. But eventually it'll get there. I think there is a lot of work to do to make sure stuff works together and the right performance and the right quality.
Yep.
And if they can solve that problem, and then maybe that'll accelerate. But and I would say also the virtualization, I was curious what your thought is on this too, is around vehicles. Software defined vehicles, another traditional metal bending business where they're now thinking about, wow, software is important. And virtualization, and we can get into the architecture, but ultimately going from a bespoke manufacturing mode into more of a software mode where things are mixed and matched on the stack. I think you're seeing those pains happening in the automotive industry as well.
Absolutely. And it's because people are looking for more capabilities in their cars. I mean, cars are, some have argued, is sort of the next mobile device. In a smart mobile device is your car. And there's some truth to that. Obviously, later generation cars do have some pretty impressive tech in them at this point, and people look to them for all kinds of activities, and information and what have you. And so there's been a lot more effort to do that. And then the other thing is because the guts of cars have gotten unbelievably complicated. And so there is this sense of down the road, there needs to be some level of simplification. And so if you can do multiple functions in sort of one, what's called ECU or electronic control unit, that's the heart of how cars are constructed these days. That can, save you time, money, energy, and effort. And so companies are starting to do it. One of the big problems, and almost nobody really understands this, is that the way car companies are actually organized, like the structure of the company, is that they were structured around these EDUs. So there was groups of people whose job was a particular EDU. So when you talk about virtualizing EDUs, you're basically talking about taking people's jobs away, because they're like, well, wait a minute, if the functions of my EDU get subsumed into this other thing, then I lose my job. I don't think that's a good idea. Right. So it's been very interesting to see that transition process. And that's part of what we've seen with, to be honest with you, as we move to electric cars, which a lot of them are software defined. Some of the challenges in terms of how they're constructed and how they're built and what have you. And that's caused some of these labor issues.
Yeah. Well, I think today, apparently the UAW got to some agreement with GM and other folks, but I think that you're right. It's a cultural issue. You should, a lot of times when companies are adopting technology, there are kind of underlying cultural issues that can really affect the adoption and the speed of adoption and the success, frankly, because you have all these antibodies in the organization. Like you said, maybe you're having different motivations around the tech. And even though it all looks good on paper, all makes sense, the CEO is scratching his head or her head about like, why isn't this working? It's like, well, your employee base is freaking out about job security and relevance and stuff like that. So yeah, no, it's interesting when all these, the virtualization of things, the cloudification of things, when it hits the ground, where the rubber meets the road, that's where it gets really interesting.
Yes, absolutely.
Hey, quick shift. Use an automotive metaphor. We'll shift. Were you at the Snapdragon Summit?
I was. I was in Hawaii.
Right. I think Leonard said he was going to be doing some jamming with you guys. I don't know.
We did. We actually played a little guitar well into the evening after a few cocktails, but yeah, we had a good time.
Awesome. Yeah, I actually talked to Megadaga last week around, she's a Qualcomm IoT kind of AI person.
Right.
Senior director. So we had a good chat about edge AI and on-device AI and what Qualcomm's doing. And I know that was kind of a big theme there. There's a lot of big themes going on. But one of the interesting things was, of course, was the Orion processor announcement and sort of, Qualcomm really, again, use my automotive metaphor, pedal to the metal with their race to build, super high performance semiconductors for PCs and other compute devices.
Yeah.
And I saw there was a lot of chatter about AI PCs.
Right.
And I think you've been around the block a few times, as have I. I worked in Windows for a while. I've actually worked on the original Windows on Snapdragon project. But you go back to AI PC, it's like cloud books and netbooks and like, is AI PC, do you feel that that's a thing, or is that just a hashtag mashup, or what's
well, it's a little bit of all of the above, to be honest with you. I mean, some of it is clearly a hype thing, but look, the fact of the matter is, there are a lot of good reasons why doing some of this generative AI type of stuff that we're starting to see on the device makes a ton of sense. One of the things that, again, Gen AI has just hit the world, with an unbelievable force, and people are scrambling to buy as many GPUs as they can and build as many big, data farms and server farms stuffed with NVIDIA GPUs as they can in order to power this stuff. And if you project out, there's not enough power and not enough GPUs in the world to power these things. So realistically, you have to think, how do I divide and conquer? And one practical way to do that is to do some of the work on the device. And the problem was everybody thought, we're not going to be able to do this. It's too hard to do. There's not enough compute power on these devices. But what we've started to see, and Qualcomm's been a part of it, but so has Intel and AMD and other folks are talking about how, hey, we can actually build, these SoCs, the system on chips, that incorporate multiple components, most notably what's called the NPU, or neural processing unit, and actually do some of these things on the device. And that all of a sudden changes the picture. And so what was interesting at the Qualcomm event was they had this new part they're calling the Snapdragon X Elite. And it has two main new features. One is the Orion CPU you mentioned, which is pure raw CPU performance. But the other big thing was they doubled up on their Hexagon NPU. And they're talking about the level of performance it can do for these AI applications on a PC. And we've already had some of that on phones up till now, but we haven't really had much of it on PC. So this is an interesting new opportunity to do it. And because a lot of the big applications being used right now are text-based, it makes more sense on a PC where we're used to using a lot of text. And even the image-based stuff, image creation and editing, is often done on PCs too. So the idea of doing more of that on a PC is actually very appealing. Now, there's a lot of challenges. You worked on the first, ARM, Windows on ARM stuff. Compatibility, that problem is not going away, right? All those x86 apps that are not going to get ported to native ARM are still out there. And How well they work is one of the questions that Qualcomm still has to answer. But for now, they just had this blowout of, hey, look at the raw performance we have both on the CPU and on the NPU. This is, a new thing. And like you said, we're putting to the pedal to the metal, and we're going to try and reshape the PC market. And it's going to be interesting to watch.
Yeah, no, I think it's fascinating. I mean, I think a lot of the x86, the long tail x86 apps with emulation usually just work fine. I mean, especially with that much horsepower.
Yeah, well, and that's what everybody's going to be waiting to see. But you're right. I mean, and we were talking about music. There's like no music apps that are going to get ported to ARM for a long time, and drivers for devices and everything else. So will those things work, and will these other specialized apps work? That becomes the big question mark.
Yeah, the specialized apps, especially that's kind of the long tail of stuff is going to be challenging. Yeah, I thought it was interesting. I mean, I actually did a paper and a couple of videos on this. I called it AI's Environmental Armageddon. So it's sort of like the appetite for AI workloads. And as you said, like building data centers and powering data centers and cooling data centers.
Yep.
Like it just doesn't add up.
Yeah.
Like there's just not enough groundwater and electricity
to
do everything, all the cat poems that people want to generate with ChatGPT, right? So if we can move some of those workloads to the interim edge or the far edge or the PC, then, why not? And with Qualcomm doing it in a much more, I call it inferences per second per watt.
Yeah.
I don't know what that is, but that kind of metric where you're looking at horsepower per power used.
Yeah.
I think Qualcomm probably has an edge over most companies in that space.
Well, and that's certainly what they're claiming. And the question will be getting support. Because as we all know, you can have the greatest, chip in the world. If there's no software that works for it, it doesn't matter. So it's all going to come down to not only delivering great hardware and a great platform, but then convincing developers to do what they need to do. They certainly have the advantage that Microsoft is very much behind them and is pushing hard and will be delivering a AI capable version of Windows that runs on these devices. They've been talking about that publicly for a while now. So that's going to be interesting to see what that does and how that happens.
Yeah, no, I think Microsoft should be able to do something interesting there especially with some of the native apps and Teams and some of the other things that they have. As far as third-party developers, TBD. It's we'll see what happens, right?
Yeah.
I think, and speaking of we'll see what happens, I think in like an hour or so is the Apple event.
Yep.
Like 5:00. So they'll talk about the M3, which my bold prediction is it's way faster than the M2. That's my prediction. And so that'll be interesting to see how that now stacks up against what Qualcomm talked about last week.
Yes, exactly.
And they have a great way. Speaking of music and other apps, for content creation and stuff in the Apple universe, they have a great handle on developers there. So
yes,
we'll see where the real AI kind of breakthroughs show up on what platform first. But makes for interesting times.
Yes, indeed, indeed.
So, other question I had for you, and I don't know if this is kind of in your bailiwick or not, but talking about RISC-V.
Yeah.
We're just talking about the Nuvia core, which is ARM based, and Qualcomm and all that good stuff, and all the interesting politics behind that. And then there's this thing called RISC-V, which is this kind of alternative architecture that's license, free license, quote unquote,
royalty free,
royalty free. But then, we've got some startups trying to do some things in that space.
Yep.
A lot of folks I know is like NXP and Schneider and a few other companies are getting together as a consortium to do some RISC-V stuff. And then there's companies like Sci-Fi.
Yep.
And who had sort of a very unpleasant implosion last week. And kind of laid everybody off, or the vast majority of folks.
Right.
And so it's sort of like, well, where does RISC-V really fit in here relative to, you've got obviously Intel and x86, and AMD is doing some cool stuff in x86. You've got ARM, which is now IPO'd with all that whole ecosystem. Whether Nuvia is part of that ecosystem or not, it's unclear. It's sort of like the same instruction set, but whatever. And now you've got this RISC-V. And like, is there enough oxygen for RISC-V to even turn into something there? I don't know.
Well, look, the way I would, RISC-V, I think, has a lot of opportunity on the low end, on microcontrollers. I mean, a lot of people don't know this about ARM, but ARM actually has 3 product lines. The A series products, which are the high-end stuff that goes in the smartphones, the R series, and then the M series, which are the microcontrollers. And RISC-V is primarily is challenging ARM on that low end, the microcontrollers. And that's, that's in everything from, a camera to a toothbrush and all these there's all these things now have little microcontrollers. So
billions.
Yes, exactly. And that's where RISC-V is a really interesting option. It becomes a lot harder to do it at a high performance scale. And again, it's not necessarily they can't design a chip. Somebody might be able to do a RISC-V implementation that from a pure, numbers perspective looks impressive, but it will literally take a decade to get the kind of software that you would need to do anything useful on a high power device. And that's why it's not really an option for the high end. It's a tremendous option for other types of devices and for microcontrollers. And I think that's where you're going to see a lot of traction. So that's my take. I mean, yes, there is opportunity for RISC-V when we think about the entire universe of computing devices, but probably not in the rarefied era of the x86 and the high-end ARM stuff.
Yeah. No, I would say that. I think that's fair. And the microcontroller space, by the way, the R cores for ARM are real-time.
Real-time, yes. I just skipped over that, but
I'm doing some digging into that. And you'll see like the NVIDIA Orin, which is a couple of big A78 cores paired with an R core.
Right.
What they call a safety island.
Yep.
So you can do like hard real-time deterministic stuff as part of your app processor thing.
Yes.
It's fascinating
how
things are getting mushed together like that.
It is.
That's a whole other discussion. But yeah, I love R cores. I think they're cool. I think it'll be interesting to see how that pans out. One of the things, like you said, the software, but also I think there's an interesting kind of deconstruction going on with semiconductors in and of themselves, right? There's things like chiplets and other kind of building blocks where you're seeing some of the big industrial folks, doing their own custom silicon.
Yes.
Right. And I wouldn't be surprised we've got Tesla in there, but other automotive folks building their own silicon over time and not relying on the latest whatever. And I think it might be getting in that direction. I'm not sure if you have any take on that. Do you think that silicon will start to get a little more fragmented and customizable per vertical? Or
I would argue that it already has. I don't know that we're going to see everybody become a silicon vendor because it's hard. It's really, really hard, not just to do it, but then to maintain it. So, I honestly don't think we'll see too many car guys do their own semiconductors. They'll customize some ARM cores. They'll do some other things perhaps. But that's about, I think, as far as most of them will go. But if you look at other big tech companies, Microsoft doing their own chips, Google doing their own chips, which has already happened, Amazon doing their own chips, which has already happened. So when you look at the big tech companies who have, a vested interest in the silicon in a way even more than the car guys do, I think you're going to, obviously we've already seen it, and I think you're going to see an expansion there. Who knows? Maybe we'll see some of the car guys start to do their own silicon. I'm sure they're thinking through it and trying to figure out what's the best way to do it. But I also think they know their limits, and they have to be very cautious on that because they could end up spending a lot of time and money on an effort that in the end isn't that useful.
They're still trying to figure out how to do software. So
they are.
And get that first. And
yes.
Then, but you're right. Silicon is a 5 or 10 year thing. You need a lot of scale to make it pay off the ROI. I do think that the cost and the overhead will start to come down with things like chiplets and other things.
Well, exactly. I mean, the other thing is there'll be a different layer or a different level of semiconductor company where they can literally sort of do a Lego block style thing. So you've got companies who've done traditional chip design, like the Cadences and the Synopsys of the world, that have these applications now that are designing systems, not just the individual chips. That's what they used to do. The EDA tools, as they call them, were the inner guts and workings of a chip. And now they kind of expanded out into systems. And ARM is doing this too. They have this thing called ARM Total Design, where they're helping companies piece together a variety of technologies, but they can pick the Lego bits that they want to get their finished, model completed. And that, I think, is going to be a lot more common for companies.
Yeah. Well, and also more fab capacity coming online. I mean, all the stuff they're building in Arizona and other places, they got to keep those up full capacity, right? So you might see some good deals out there for fabbing $1 million of something or $1 million of something else. I don't know.
Yeah.
But, and then also, I think with EDA, how do you infuse, and I'm sure this is happening already, AI into some of the EDA processes?
They are already doing that
pretty quickly and just put the blocks together and spit it out.
Yeah, and they're doing it for better designs. They're doing it for more power efficient designs. But they're deploying AI and generative AI stuff already, and it's having a huge impact.
Fascinating.
Yeah.
I had a kind of a meta question for you, being in the business and doing all these things. Like, you have a broad portfolio of things that probably throughout the day you're talking about, thinking about, writing about. How do you kind of organize your head?
I love what I do. And so all this stuff is interesting and fascinating to me. And I love making connections across things. And that's just kind of how my brain works. And part of the reason I left IDC, as much as I enjoyed my time there, which I thoroughly did, was I wanted to expand to bigger and broader things and tell broader stories that connected more industries, more people, more companies, because I thought there were a lot of things out there that weren't being told. Because with big analyst firms, you tend to be very specific and very deep, which is great, and there's absolutely a need for that. But I thought there was also a need for a different kind of perspective, a broader perspective, and that's what I've focused on. And so it's kind of how my brain thinks, and I get bored easily, so
that's good.
And I like to jump around, and I'm able to do that, and then figure out how this stuff fits all together. So
no, I hear you on that. I mean, one of the things I always like to do is look at the combination of technologies. How does 5G and AI and edge, come together? And it's like the chocolate and peanut butter analogy,
it's
or whatever.
The tech
it's like,
this is a whole new buzzword thing. Bingo, to get all those things working together. But
but then it's like they all have impact on each other too. And so sometimes, like we were talking about AI and now EDA and chiplets, and now all of a sudden things get combined together and enables a whole new way of building and delivering tech. Which is kind of cool.
Absolutely true.
Yeah, I get that. Good. Well, Bob, again, thanks for your time.
You're welcome. Happy to have joined you.
You seem to be extremely busy, and so I appreciate you carving out a little bit here.
Yeah.
And I see your guitar in the background. I don't have my guitars in my background.
It's all good.
There's a Martin back there. But yeah, hopefully we'll run into each other again at one of these events, and have
Sounds good, Pete. I appreciate you having me on.
Thank you very much. All right. Thanks, Bob.
Take care.
Thanks for joining us today on the Excelsior Show. Please subscribe and stay tuned for more, and check us out online about how you can scale your edge compute business.